Good afternoon, everybody, and welcome to the Intersection Safety and Operational Assessment Process presentation today. This presentation will be presented by John Liu from the Deputy District Director of District 6 in the Division of Maintenance and Operations, Jerry Champa from the Caltrans HQ Division of Safety Programs, Phil Russ, City of San Diego, and we're also going to have a little guest spot here for Rachel Carpenter, who is the Caltrans Chief Safety Officer. For those of us just joining us, we are recording this presentation for future use and distribution to all those who have attended, as well as for those who were not able to attend, we will post it publicly on Caltrans, on one of Caltrans's websites, or onto the California Local Technical Assistance Program Center. That's caltap.org. I'll go ahead and type that in here. So without further ado, I'm going to go ahead and introduce our hosts, John Liu, Jerry Champa, and Phil Russ. Go ahead and take it away, gentlemen.
Hi there, good afternoon. Again, my name is John Liu. I am the Deputy District Director for Caltrans District 6, Division of Maintenance Operations. I am based in Fresno. And this webinar is for the rollout training for our new ISOAP, which is Intersection Safety and Operational Assessment Process. And as mentioned before, I will be joined by Jerry Champa. He is a retired annuitant from our Caltrans Headquarters Division of Safety Programs, and also will be joined a little bit later on by Phil Rust. He's a traffic engineer for the City of San Diego. So before we get started, I'd like to go ahead and introduce the Chief Safety Officer for Caltrans, Rachel Carpenter, and she's just going to have a few opening remarks. So Rachel, can I pass it on to you?
So I was just mentioning the serious number of people that have died in traffic crashes last year. So based on provisional data, that was about 3,581 people. And what's more is that about a quarter of those deaths occurred at intersections. And as safe system practitioners, we know we can do better. We know that humans make mistakes, and it's up to us as system owners and operators to build a forgiving environment for the traveling public. So we need to improve our decision-making framework to ensure that the most appropriate infrastructure solutions are chosen, especially in times of constrained funding like we are in now. So enter ISOAP. ISOAP is our new intersection safety operational assessment process, and it is safety, intersection safety performance we know can be enhanced by implementing principles of the safe system approach through methods like minimizing or modifying conflict points, reducing vehicular speeds, improving visibility, and providing space and protection for vulnerable road users like people who are walking, biking, or scooting. And as an example, roundabouts do all these things. So roundabouts are a safe system strategy and an FHWA proven safety countermeasure. Roundabouts can also be implemented in quick build style, where temporary installations can test the design and allow for an opportunity to gain community acceptance. And these are key points to make when discussing roundabouts. And ISOAP is much more than just roundabouts, but engagement, is another key to implementing ISOAP. So our practitioners from various specialties must be included throughout the ISOAP process. So staff from not only traffic safety, but traffic operations, project development, complete streets, local development experts, and others, really need to be involved. And implementing ISOAP also requires orchestrating outreach to inform the traveling public, as well as elected officials and other decision makers and stakeholders. ISOAP is new and will require introduction to many people. Gently explaining and persuading practitioners is key to implementing the safe system approach in California, and ISOAP is no different. So through engaging and involving others, we demonstrate the safe system principle of responsibility being shared. Everybody has a role to play in advancing our Vision Zero goal, and we must use every communication channel and tool that we can in order to achieve our goal of zero deaths and serious injuries. ISOAP is our newest tool, and I encourage all of you to embrace it. And I'm so glad to see so many of you here today on this webinar. And I thank you so much to John and to Jerry in particular for all of their work in developing ISOAP. I have no doubt that it's going to help us reach our zero goal. So with that, I'll turn it back over to you, John. Thanks so much.
Great. Thank you so much, Rachel. We know you have a very, very busy schedule and you have to take off to another meeting, but thank you so much about talking about the importance of intersection safety. Thank you so much. So today's webinar, there is a lot of content, but the intent is just to give an overview of ISOAP. So we will be having some in-person workshops. I'll talk about that a little bit towards the end, but also we want to hear feedback. Are there specific topics where you may be interested in having a follow-up webinar? I'm also open to having meetings with individual agencies, different districts. So please let me know of your feedback. We also actually update ISOAP in about 12 months. So again, we want to hear your feedback about what works well, what needs improvement. Any kind of suggestions would be great. So the slides are available. If you haven't checked the chat, they are in the chat. So you could go to the chat, download it. The slides will also be posted on the Caltrans ISOAP website. So all you have to do is just Google ISOAP. The first link would take you to the Caltrans ISOAP website. So as far as the presentation, we're going to cover a lot. The background, the key changes from ICE. Jerry's going to talk about safe system approach because that's our new way of designing and operating the state highway system with keeping safe system top of mind. We're going to talk about the various types of intersection control strategies. When do we do ISOAP and what does it apply to? So it's only for state highways. But it's also, we suggest that you incorporate a lot of the concepts onto the local road system as well. Roles and responsibilities, some of the analysis tools, the various stages and steps of ISOAPs. If we have time, we'll cover a few case studies and questions and answers. So after some of the sections, we'll take maybe 1 or 2 quick questions, but we're hoping to have about 15 minutes towards the end to answer questions. But also, please enter your questions in the chat. We'll try to answer questions in real time as much as we can, but we also want to have discussions as well. So as far as the background, as I mentioned before, ISOAP replaces intersection control evaluation, which has been in place in Caltrans for about 10 years. And it's really been effective to have us look at other types of intersection control options besides signals. Signals were always kind of the go-to treatment. But we know that in many cases, there are better, safer, better operating treatments, whether it's roundabouts, and there's other types of treatments, whether it's restricting movements, R-cuts, some things, configurations that Jerry will be talking about later. But we knew that we had to update ICE because it hasn't been updated for 10 years. Many other states, and about a third of the states have some kind of ICE process. And several states have had many iterations with improvements. So we really wanted to work with our partners at FHWA. They had their consultant, VHB, come on board. And we developed over the past 2.5 years, the new ISOAP. And we also wanted a rebranding that really kind of emphasized safety. So safety is part of the actual name of the new process. So going back in time, what was ICE? ICE was a framework to make decisions for intersection control. It wasn't really meant to be a new process. It's just a framework to help guide the decisions that are to be made. It was a 2-step process. You had your initial screening, which was kind of the fatal flaw analysis, just so that you could drill down to look at the most viable potential alternatives. And then you went into the detailed engineering analysis. And that's going to be very similar to with what we're doing with ISOAP. We didn't want to start with a blank slate because a lot of ICE actually worked very well. So we really wanted to build upon ICE and just make it a little bit more effective. And why did we need to kind of update ICE? besides the length of time, but Caltrans, we do have a lot of new strategic directions that we're trying to incorporate in how we could better design and maintain and operate our state highway system. A big emphasis on complete streets. We have a Director's Policy 36. And here we have our Vision Zero target for 2050, where we want to eliminate all fatal and serious injuries, not only on a state highway system, but on the entire transportation network, including the local street and road network, tribal lands. SB 743, this is where we're de-emphasizing level of service. We're trying to reduce vehicle miles traveled. We really need to have our existing transportation network be more effective, be more efficient, and especially be safer. We have new ways of dealing with climate change and new ways of looking at making the best investment decisions. And as Rachel earlier commented, about 25% of fatal and serious injuries happen at intersections and access points. And of that 25%, actually about 80% actually happens on the local road network. The state highway system, we have a lot of controlled access highways, but certainly we have a lot of interchanges. We have a lot of conventional highways where we will be going through ISOAP to look at those access points. But there really needs to be a lot of improvement on the local road network as well to really have these better safety outcomes. So we're hoping that a lot of these concepts will be adopted by local agencies. So our outcomes, improved safety. That's our number one outcome, especially for the vulnerable road users, the pedestrians, the bicyclists, the transit users, the people who are on scooters. We know that as we're doing less and less freeway building, freeway widening, we're going to have more traffic on these conventional highways and local streets where we have more potential for conflicts. And we want to make sure that we're making it as safe as practicable. We also want to make sure that we have more implementation of cost-effective intersection improvements. A lot of times we're trying to look for the best treatment, but then we cannot always afford that. So what can we do that's affordable, that we could implement systemically, but that's also going to get us to the safety outcomes? We also want more consistent application of intersection control across the department, across California, because right now every district kind of has their own little flavor. We want to make sure there's a little bit more consistency, especially when we're dealing with local partners and consultants, so that they really know what to expect when they are doing an intersection evaluation. And finally, we recognize that support resources are very, very limited. So we want to make sure we have a process that has a lot of value. We're not just doing things just to check the box and say we did it, but we want to make sure we have a process that's going to get us to the best performance and do it very, very efficiently. So some of the key changes going from ICE to ISOAP, we have a little bit more guidance as to what should be included in analysis. And I've already talked about specifically addressing the vulnerable road users, also looking at freight as well as various other aspects, which I'll be getting into a little bit more detail. Standardized forms. We want to make sure that it's, as far as the presentation of the data and the recommendations, we want to make it easy. You don't have to necessarily write a very, very long, detailed report. So we have some new forms that we have developed to make the presentation of the information very easily. We require the use of the Highway Safety Manual in the stage 2, which is the detailed analysis, if it's applicable. So the first thing I want to mention is a lot of times you're going to only need to go through stage 1 and not even get to stage 2. But if you do get to the stage 2, we would like you to use the HSM if it is applicable. We are using the HSM for more and more of the processes at Caltrans, including our DDSD design decision documents. And finally, if the recommendation is not something that is readily fundable at this time, we want there to be a little bit of effort to see how could you actually get a little more funding to get to the right solution. Because a lot of times you build something, it's going to be there for 20 years, or it may be there forever. Whereas if it takes a little bit of effort to look for some other funding resources, maybe we're going to come to a solution that we're going to have better overall safety outcomes, and that's what we really want to see. So the solution needs to support a safe system approach, and this is also very context sensitive. So when you're looking at locations with a lot of access points, a lot of vulnerable road users, that's where we're going to want to make sure that our infrastructure supports those types of users. And we also want to make sure that our staff over in our traffic safety branches concurs with the recommendations that are ultimately made for the intersection control. And we do have some streamlined processes for a couple situations. The first is you can automatically go to a stop sign if it's a very low volume access point, and where signal warrants are never going to be met, and there really aren't any kind of special features or special conditions that really warrant additional controls. The second streamlined process is for single lane roundabouts. So if you have relatively low volume, 25,000 ADT, you could go directly to a roundabout without analyzing the signal as an option, as an alternative, if signal warrants are going to be met within 10 years, or if you have a crash history that would be addressed, that can be addressed with a roundabout or signalization. And also if the cost of the roundabout is somewhat commensurable to signalization. We do know that a lot of times there is public concern, there's controversy. So if you are expecting that, or if you're having to go to an eminent domain process, you're going to want to go through a rigorous environmental process and look at various options and alternatives. So just keep that in mind if you do plan to use a streamlined process. At this point, I'm going to go ahead and hand it to Jerry. And Jerry, you may also want to give a little bit more introduction to yourself. And or Daniel, are there any questions, quick questions that we can also answer at this point?
We do have a question, John. Thanks for asking.
Yeah.
We have one question that states, can you elaborate on what you would like to see as part of the HSM analysis in stage 2? Is Caltrans planning to update their HSM application guidelines?
Great question. And one thing that we recognize is not a lot of folks are experts on the Highway Safety Manual. And there's actually going to be a revision to the Highway Safety Manual, which is a document that's put out by the feds. So within Caltrans, it's our division of design that takes the lead as far as providing support and training. And this is where our local partners and the consulting engineers, my recommendation is to work with your districts to see what training the districts offer. I can't specifically talk about what additional guidance or training that our headquarters is going to be providing. But because there's a lot of changes coming to the HSM, I would expect that there would be additional guidance. So later on, we will be going through an example that will cover an example with the HSM. So we have time, we'll briefly talk about that. But I know the HSM in itself is something that requires a lot more training. So that's certainly some feedback that I will be taking back as well. So thank you, Daniel. Okay, so at this time, let's go ahead and get Jerry. And if you want to talk about the safe system approach, and again, give a brief introduction of yourself as well.
Okay, thank you, John. And I want to first say that I'm here today probably or mostly because I've been involved during my career at Caltrans, probably close to 25 years of it, working basically towards implementing and helping to address how do we utilize innovation. And my involvement with intersections started about 23 years ago, and with roundabouts in particular about the same time. And during my career, I've had a lot of engagement with folks at the local level, Caltrans districts for sure, and with the FHWA. And the last part of my experience, probably the last 5 to 8 years in my career, was working to help implement what were then considered innovative solutions. And a lot of these were focused on interchanges. And we're still working very hard to implement these. And the good news is evolution continues. So the solutions have evolved, and the good news is they've become a lot cheaper and a lot easier to install. And so we're going to cover that. Remember, ISOAP is basically, I refer to it as a tool. It's going to help you as practitioners to basically identify the best solution for access related problems, or not a problem, just a new intersection or interchange. So this is a lot of innovation and a lot of good stuff to share with you. Today, we're just going to do kind of a virtual tour, or I'm going to cover a virtual tour of that. Let me start, though, very quickly in talking about the safe system approach and as it pertains to intersection safety. Of course, we're going to talk about those solutions. The thing I want to emphasize to start here is what Rachel referred to, and that we know one of the differences with safe system is that we know that humans make mistakes. We know that road users make mistakes, and we know that road users are vulnerable, especially pedestrians and cyclists. And you might think also older travelers. Another thing to emphasize as we go through this and later in the program, Phil Rust in particular, talking about how important redundancy is, redundant systems to get to the outcome we want, which is zero, eliminating fatal collisions. Next slide. And again, humans make mistakes, road users make mistakes, and everybody makes mistakes, and that's part of being human. So really the question here that's being addressed is, why should people have to pay the ultimate price when they do make mistakes, unintended? Let's go forward. Thank you. The other thing to really keep in mind today, what's important about the safe system approach is its emphasis on safe roads or infrastructure, and in particular, infrastructure that produces the speeds that are safe. And this is where there are a lot of strategies for intersections, some of which get partial reductions in speed, others get full or 24/7 reduction in speeds to a safe speed. Everyone should be very familiar with this type of diagram, which basically explains how vulnerable users, peds and bicyclists, their survivability depends on the speed with which they're hit by a vehicle. And getting down to about 20 miles an hour is really getting close to preventing. So even when there are crashes, when the vehicles are going at a low rate of speed, the pedestrian or cyclist chance of survivability is very high. And this is kind of the goal of a safe system. To go one step further, sorry, speed is about the most important thing that we can affect to get a safe outcome, and to some degree, better capacity and operational performance as well. But the key here, and I want to make this statement from this quote, without speed, unfortunately, there can be no movement. So we need speed, and certain facilities can have higher speed. So we're looking for an optimum speed, that which will avoid severe outcomes, but which also provides for mobility. And the main point here is that ISOAP is a tool, it is a process, it is a tool that helps us identify the optimal solution, not just for safety, but considering the most important goals that we have, mobility being one of them, even environmental goals. Let's go forward. So I'm going to talk now about safe system intersections, and let's just go forward. And what's important today is we know that traffic safety has for a long time been a reactive, a practice that is in response to problems. And we do have programs now and emerging. They're looking at systemic safety and doing things proactively. But ISOAP is proactive in a way. It's used for all project or capital projects that include intersection or interchange improvements or the addition of those things. So it's not just for projects at spot locations, but could be long corridor projects in which access is part of the solution. But so again, what we're doing is we're considering the safety risk and also the outcomes for all projects, not just looking at safety within the context of a safety improvement project. So whatever the capital project is, if access is part of it, then ISOAP will help us identify the optimal solution based largely on how the different alternatives perform in terms of safety performance. And again, just kind of to touch on where we have been and where we're going with the safe system approach. And I think ISOAP is doing all of this right now. I want to mention a few of the things that are highlighted here. The traditional approach, reducing crashes, has always been a goal. And of course, now the focus is on preventing death and severe injury. Traditionally, we've been trying to improve or help drivers and others make better decisions, good behaviors. Whereas the safe system approach acknowledges it and says, let's just design for those mistakes. We'll never prevent them. From a traffic calming and speed enforcement, always trying to accomplish lower speeds with tools that can't get us there. Safe system is now focused on reducing the transfer of kinetic energy when there are crashes. So again, acknowledging crashes are going to happen just like people make mistakes, but let's lower the outcome or reduce the outcome. Of course, designing for peak conditions has always been something we do, but now we want to look at all conditions, including darkness. And we'll get into even comparisons on some of the solutions that are safe system and others that have safety as part of the benefit. Let's go forward. So one of the things that the FHWA, again, guidance and actually a tool in this document that came out last year, it established a safe system hierarchy. And of course, there's a hierarchy for intersections as well. So another tool to help agencies and practitioners identify and prioritize strategies when developing projects. And these are provided in 4 tiers, arranged from the most aligned with safe system principles to those that are the least aligned. Let's go forward. And again, these tiers, as you can see, the tier 1, the best solutions are those which remove severe conflicts. Second tier is reducing vehicle speeds, which basically can go together very well, and both equally important. To a lesser degree, managing conflicts in time, talking about traffic signals. And increase attentiveness and awareness, tier 4 of the safe system principles. Let's go forward. Now, these are examples of strategies which are identified as being aligned with tier 1 of the safe system. And again, the whole point of this hierarchy is that when applying this to projects, agencies could always consider the countermeasures and strategies under tier 1 at first. So that should be the first and foremost prioritization of improvement alternatives, looking at tier 1 first. And these are, we'll cover these in a little bit detail, especially on the left, what's called the reduced left turn intersection or R-cut. We see roundabouts and also the diverging diamond interchange. Let's go forward. Okay. So going back to early slides, I pulled off a few of the things that are more important. So to see if we are working and pursuing improvements that are in alignment with safe system, these are the keys. These are principles and elements. And I've already mentioned these. I want to come back to these in a minute. Next slide. So as an example, and so looking at those same safe system principles and elements on the left side of this table, a quick comparison of intersection improvement alternatives and comparing signals with roundabouts. One thing that we need to mention here is that roundabouts, of course, are a safe system strategy, but they're also a proven safety countermeasure, whereas signals are not. And so it's no surprise when you compare these for these new principles that we're trying to attain, you see that roundabouts are basically far better than the signal alternative in terms of things like reducing the impact of mistakes, reducing kinetic energy when there are crashes by managing vehicle speed and crash angles. So again, eliminating death and incapacitating injury, roundabouts known to virtually eliminate those. Signals do get some relief, but not as much. Let's go on. And so again, we're not starting, but I think the point is if you go back to looking at where do our most severe crashes occur on the smallest part of the overall transportation system? It's a lot easier to focus on access points than on segments and corridors, or you might say it could be less expensive as well. And so it's very logical to look at intersections as we jump off. And I think some of our partners have already done this, looking at intersection safety programs in particular. So again, looking at where do we start, or where can you start as an agency? Intersections are definitely should be prioritized. Let's go forward, John.
Jerry, I'd like to just interject here for a moment. If anybody does have any questions, can you please place them at the Q&A box at the bottom of your Zoom screen? It should either be in a box with a question mark, or you may have to hit the More button, which will have an ellipsis or 3 dots at the bottom that's circled. Just click on that, and the Q&A box will appear on there, and click that and ask your questions. We did have one question here thrown into the chat. It says, please define stage 2. And this is from the second section, I believe. Is the highway safety manual required during the project approval and environmental documents, or planning specifications and estimates phase? This may be a question for John as well.
Yeah, I'll go ahead and answer that. And I will be covering that a little bit later in the presentation. But typically, stage 2 is going to be done during the PA and ED, the project approval and environmental document stage. So that is when the HSM analysis will typically be done.
Excellent. Thank you, John. We did have one other question here. It says, Main Street communities in rural areas often advocate for roundabouts as a traffic calming measure. What is Caltrans and FHWA policy on allowing local communities to install roundabouts on Class 1 roadways if they obtain the funding? And would signals be warranted or not?
Again, we can talk about that now, but maybe it would be better to respond to this after we get into a little bit more detail in the process. The answer is yes, of course. Safe system solutions and the best solutions should always be embraced. I think we can talk about this in just a few minutes, talk a little bit more about signal warrants.
Yeah, and I'll just make a quick comment is that ISOAP is all about making engineering judgment, doing the right thing. And it's not really a prescriptive process that gets you to the solution. There's a lot of engineering judgment. And similar to roundabouts, they don't have warrants. You use engineering judgment. You put them in appropriate locations based upon an engineering analysis. So the answer to that question is absolutely. If there's an engineering reason why you want to put a roundabout on a rural main street and it makes sense, and you do your engineering analysis, then by all means, if the funding is available, that could very well be the right solution.
John, I do want to add, and actually it's something that I skipped covering on a previous slide. We don't need to go back to the slide, but in talking about our traditional approach versus a safe system approach or a evolved approach, largely, and this is still in transition, but decisions about intersection traffic control have been always based on, if you meet a signal warrant, you can proceed to study and pursue the installation of a traffic signal. It's kind of outside or irrespective of, well, how safe will a signal be compared to other alternatives? And so we're able to say that, yes, signals can be a solution when warrants are met. And as John just said, whereas roundabouts, they don't even need to meet a warrant. And one of the main reasons for that is they do not create the significant side effects or traffic impacts that signals and always stop control are known to impact. So we don't want to just throw a signal anywhere at an intersection, whereas a roundabout, if just slowing people down, calming traffic, providing better access and safety, if those are the goals, then roundabouts can accomplish that without having a negative impact on traffic flow, capacity, et cetera. So I think some of the examples, case studies later, John will be walking through, will help explain this a little further. Good question, though. So let's go back to the other strategies. In addition, I've talked about roundabouts and traffic signals already. And so let's go forward and look at the list. Okay. And, this is basically a menu, maybe 80 to 90% of all the possible configurations, traffic control strategies. They are evolving, and we don't have to limit ourselves. Sometimes the best solutions are evolved, they're modifications of these basic strategies. What's important here, the highlighted strategies are those that we'll cover a little bit more detail. And these are proven safety countermeasures. And that's why we want to look at these first, because they are solutions for all access or new access, but they also have the best safety performance. Let's move forward. One of these, pedestrian hybrid beacon, definitely a proven safety countermeasure, but it's got limited applications. This is really for ped crossings only, and it works part-time. So it has a minimum impact on traffic flow, unlike signals, but is very effective. Let's go next. I want to talk about and then get into showing you a couple of the examples of what are overall called reduced left turn conflict intersections. People might know these better under the terminology restricted crossing U-turn or R-cut intersection. Basically, this is taking movements or converting movements at an existing intersection and converting those and relocating those, in particular the crossing movement. And in this case, allowing drivers to turn right in order to go straight or to go left. So definitely has pros and cons with respect to mobility, but is proven to be safer. Just to give you a better picture of what this looks like and how it can be very accommodating for pedestrian and bicycle mobility and safety. This shows you that prominent crossing when signals are applied at an R-cut intersection. Next. And again, these benefits here ranging from primarily around 50% up to 63%, depending on the type of controls added to those intersections. And again, the intersections are at the major, but also U-turns introduced on either end. Let's go forward. Roundabouts. This is worthy of a virtual tour because there are now so many different types. They come in all shapes and sizes. And of course, that means costs as well. And the good news is there are much lower cost versions of roundabouts, in particular the smaller roundabouts, which are emerging as being very effective for a significant range of volumes. So let's go forward and really just to kind of cover this. Roundabouts do more than improve safety, obviously. They calm traffic. They do handle traffic more efficiently. No waiting, no stopping when there is not a conflict is the main reason for that. So operationally, they are they're as good as you can get at an intersection control strategy. Move forward. For safety and a safe system approach, this is very important. And again, the distinction here, this has been known for a long time, and various studies have supported this finding. Converting an existing intersection that is signal or controlled by stop signs gets about an 80% reduction in fatal and injury crashes. And even more importantly, a 90% decrease in terms of fatal and the very severe crashes. This means that, of course, this is showing the difference between the safety performance of roundabouts and traffic signals. Let's go forward. And I want to touch on also a little bit more about this hierarchy of solutions, design solutions and traffic control solutions. Roundabouts are emphasized now in this hierarchy as the top tier 1 intersection, safe system intersection. And there are various reasons. Again, they're limited here. They do reduce the crashes for all road users, not just for vehicle cars. But what's important here is that right now, this is still an underutilized solution. And ISOAP is a tool to help us integrate this better into decision-making. Again, the range of applications, I want to go through this quickly. Roundabouts can be the key for road diets to work in terms of being able to implement a road diet without causing a problem or redirecting traffic, diverting traffic to other corridors, because it's been proven that you can eliminate or replace the traffic signals to get narrow roadways, and roundabouts handle that traffic. Let's move forward. Again, alluded to the fact that we now have so many different shapes and sizes, and there's a term that's come out in the last 10 years or so of calling these affordable roundabouts. And so these actually can be installed for a fraction of the funding and the time that's required for the conventional size of roundabouts, and even materials and construction methods. Again, these range from quick build on the left, which can be done as an interim project using work zone materials, until funding can be found for permanent solutions. The mini roundabout in itself, just because it's smaller, has a smaller footprint, and that means lower cost, especially when we start getting into right-of-way costs. This can avoid that. And then on the right side, another affordable roundabout is the modular concept. And this is another important development, because it can also be applied, modular meaning prefabricated components that are basically installed onto or nailed to the pavement in general. This means that if you think about footprints in 3 dimensions, we're saving work instead of excavating, which we normally do to do repaving. This avoids much of that expensive excavation work, by being able to work within an existing intersection footprint, and basically the installation is on top. Other just examples of affordable and quick build roundabouts. Already showed a picture on the right, a modular on the lower right. And this is actually in the lower here is another form of a quick build roundabout, which can be done again with almost semi-permanently installed work zone features, channelizers and such. The modular, again, recycled components that basically can be used to install curved islands. And of course, roundabouts are a bunch of curved islands if you think about the central island and the splitter islands approaching on each approach to them. But this is also good news. Modular products can be installed for a variety of other islands, including for protected bikeways, pet refuge areas, median crossings, etc. Go forward. And I want to mention quickly, this is kind of the first of case studies that can be shown. But this one we learned about just recently, and I think the evaluation of a corridor project. This is from Cleveland, Ohio, where many roundabouts were installed in the corridor, I believe 7 in all. And we can now report the preliminary performance, the benefits out of this project. The 2 pictures here show the pre-project condition, a series of traffic signals along a collector arterial through a residential neighborhood, an older neighborhood, 2-lane road. And then the post-project looks, you can see the yield signs representing mini roundabouts. So basically they installed 7 roundabouts, eliminated 6 traffic signals. Next slide. This is just to give you a glimpse of the finished project, a product looking at mini roundabout. Nothing spectacular here. This is very straightforward, but gets a big difference in performance. More projects to show how these are working and handle large vehicles in particular. And they have been, according to the city of Cleveland, they have been doing well for all traffic users. And most important, just wanted to share the post-evaluation progress so far. And what's most important here is the change in speed, pre-post, and reduction in crashes. The speed was reduced. This was one of the goals, taking what was signed as a 35-mile-an-hour corridor. And the observed speed afterward was down around 23 miles an hour. So the city has already changed the posted speed limit. It is now a 25-mile-an-hour corridor. And the observed crashes, reported crashes, I should say, so far include only 1 minor. And this was one of the motivations for the project. It was a crash-prone corridor, including severe crashes over the years. This slide, this is just in case you want to learn more about this. There's a Facebook, I'm sure you can get a copy of this presentation. And there is a Facebook link on this slide. Thank you. Next. And to wrap up, again, not quite done with the roundabouts yet. The latest is the turbo roundabout, which has a higher capacity. So definitely something that is relevant for ISOAP and looking at where capacity is a problem. Instead of continuously widening intersections in order to help traffic signals handle peak hour traffic, larger roundabouts are providing good flow and capacity as well. Question is, do they provide the same safety benefits as the smaller roundabouts? And the good news is that they are, based on international experience, at least so far, getting a very good reduction in injury crash frequency, 76%. Next. The last of the strategies, again, mentioned in the FHWA's roadway design safe system hierarchy. Diverging diamond interchanges. There are about 80 now in the US, and I know several in California. Let's go forward. This is identified as a tier 1 safe system interchange configuration, largely because it eliminates most of the crossing type crashes that you would see at conventional signalized or stop controlled intersections. We won't get into the detail here, but the problem is, if you just go on looks, it looks like it could be very daunting for not just drivers to get through, as shown in this picture, but for pedestrians and cyclists. But the good news is that the performance, like roundabouts, has been very good so far. Next. Oh, I'm sorry, just go back real quickly. I think what I wanted to emphasize here was so far the reduction in crashes is about 44%, and that's fatal and injury crashes where DDIs have been installed and evaluated. Let's go forward. And I'm going to skip this until later and see if that, yeah, John, I want to hand it back to you.
We did have a few questions here in the Q&A box.
Okay.
We have one question asking, are the pedestrian hybrid beacons replacing the HAWK or high intensity activated crosswalks?
Okay, so just to clarify, a pedestrian hybrid beacon is the same thing as a HAWK. It is a different terminology, and the HAWK terminology is actually a little bit outdated. So we would actually like to stop using the HAWK and call them PHBs or pedestrian hybrid beacons. But they are identical. There's no difference.
Excellent. Another question. Do you expect a report or memorandum to accompany the ISOAP forms, or will the form be adequate by itself?
So I'll get into a little bit more into the forms, but there is no reason to have any additional documentation beyond the forms. If someone wants to write a cover letter or a cover memo, they certainly can. There is no requirement to actually use the forms. If they feel more comfortable in writing a more of a report format, they could do that as long as they cover the pertinent information.
Thank you again, John. Mini and modular roundabout are not accommodating to an STAA truck, correct?
I think that the question should be, are mini roundabouts, whether they're modular or permanent, are they accommodating to trucks? Both are accommodating to trucks. And the key here is that roundabouts can have a traversable island or a non-traversable island. Many roundabouts have to have a non-traversable island if large vehicles have to be accommodated, and even most emergency response vehicles. But the answer is that they are accommodated.
And Ron Hall has commented, a quick build at SR 191 in Durham, Pence was placed to handle haul out of burnt building materials after the fire in Paradise.
Yeah, so that was a large temporary roundabout that was installed by a director's order. My understanding is up in District 3, where it was built, that they are looking at putting features to make it more of a permanent installation. Now that roundabout was not inexpensive. It was still quite expensive. It's quite large because it is accommodating very large haul trucks. But the same concept could be applied to smaller, more affordable, temporary or quick build type roundabouts as well.
Excellent. Thank you, John. What is the liability, or is there a liability for installing roundabouts, especially if they are not warranted?
John, I'll start by saying there are no warrants for roundabouts, first of all, so there is really no reason to even bring that up. That's really not relevant to the engineering decision that's being made. ISOAP is the framework within the engineering studies are performed to help us make these decisions on which strategy is the best. So again, basically following ISOAP as a guide at least, and documenting findings from the ISOAP process, the studies that go on. That's all that is necessary to basically avoid any tort liability. John, do you want to add to that?
Yeah, just because you're not designing to specific warrants doesn't really change tort liability. I mean, the fact that we are owner operator of a transportation network, we're exposed to liability. As long as we're making engineering decisions based upon the best information out there, we will still have design immunity as long as we are documenting our decisions and why we are designing things the way we are.
Time for a couple more questions here, then we'll be moving forward. So unless the designer is trying to create gaps, is a 22-mile-an-hour roundabout preferable to a 17-mile-per-hour? Just thinking out loud here, the attendee asks, or comments, I think traffic can densify from 33 down to 22 without losing throughput past a point, but perhaps not below 22. What are both of your thoughts on these concepts?
This is getting into some pretty detailed performance checks, and I think there's a lot of things that you really have to look at. Looking at the design vehicles, you're looking at the volumes of pedestrians, the size of the roundabout. Think about roundabouts, they are very forgiving. Even though if it's not designed perfectly, more than likely it's going to operate very, very well. And what we try to do, especially when you're in a constrained situation, is make the best design that we can. So there really is no easy answer to that question because there's just so many variables.
I want to add, and again, this is the importance of ISOAP and the safe system approach. These are important questions, but what's most important is to compare how will that small, large roundabout perform compared to a traffic signal or some other strategy. So it's, comparing a different version of a roundabout, fine, but I think the basis of decisions is comparing how these different alternative solutions are going to perform relative to each other. That's what ISOAP does.
Last question. Thank you everyone for the excellent questions today. Thank you for covering more affordable roundabout types. Do these types of roundabouts, especially in the smaller diameter roundabouts, conflict with page 15 of the new ISOAP guidance that states standard geometrics in the HDM and Design Information Bulletin 94 should be used in determining intersection footprints, including appropriate sizing of roundabouts?
So we know that the Highway Design Manual, it doesn't cover every situation. And we don't want to be unnecessarily bound to existing guidance when there is innovation, other best practices. So we definitely do want to follow the Highway Design Manual, but we do have a process when we want to deviate. So again, it's about making the best engineering decisions to get to particularly the safety outcomes.
Yes.
So I'll just say use a lot of judgment and documentation. So Jerry, if you want to add?
Yeah, and actually I'm going to invite, if they already haven't done so, one of our headquarters design roundabout subject matter experts, and especially experts on intersection design policy, if they would enter their answers in the chat box. I'm not aware of any conflict. I've talked with them, and many roundabouts are fine. They are not non-standard. They are not an option that should be discarded. They do comply. If they're designed well, they do comply with the design policy and criteria.
All right, thank you both. Go ahead and continue on with the presentation.
Alrighty. Okay, so the next section is talking about the applicability. So when do we actually have to do ISOAP, and when do we do it? So as I mentioned before, it's only for intersections or interchanges on the state highway system. But if it's going to be a new connection to the state highway system, and if it's going to be a driveway, if it's a high volume driveway, we do want it to be covered under ISOAP. Brand new freeway interchange, you'll have to go through ISOAP. If you're changing the type of traffic control, you're going from yield to a stop to a signal, that will trigger ISOAP. If you're putting a pedestrian hybrid beacon at an intersection, you'll have to do ISOAP. If it's a mid-block, not necessarily, but we want to make sure that if you're doing it at an intersection, that it's the right treatment, as opposed to, say, rectangular rapid flashing beacons or a traditional traffic signal or some other kind of treatments. Or if you're making any kind of physical change, doing some widening, just spending a lot of money, that's really another reason why you want to go through ISOAP. We want to make sure that we're making the best investment decision. So conversely, when do you not use ISOAP? So if you're only restriping, if you're doing a road diet, but you're not actually changing anything with the physical roadbed, then you don't have to go through ISOAP. If you're doing a road diet, you're going to want to do an operational analysis, but you're not going to have to go through all the steps and stages of ISOAP. Any kind of signal modifications, changing timing, software, if you're restricting movements, if you're putting a worm, a diverter, if you're putting a right turn only, if you're doing an R-cut without any kind of widening, technically you don't have to do ISOAP. Go ahead and do the operational analysis, look at any kind of diversion impacts, but you don't actually have to do ISOAP. So as far as when do you do ISOAP? So just like with ICE, you would typically do the stage 1, which is kind of like the fatal flaw screening during the PID or prior to the PID. If you're doing like a conceptual report, then you could go ahead and, if you have the information, to go ahead and do stage 1 of ISOAP. If it's necessary to do stage 2 because you have multiple potential strategies, then you would typically do it during the PA and ED stage. Now, you could always do it before the PID or the PA and ED, but if you have more information that arises, for instance, during the environmental document, by all means, you could absolutely reopen stage 2 of ISOAP and do a reevaluation. So I'm not going to have time to go into all the stages and steps into detail. I'm going to go through them really quickly. But stage 1 does have multiple steps, which I'll cover very quickly. And then stage 2, a detailed analysis, likewise. So when do we typically cover ISOAP? So I mentioned that if stage 1 is during for a capital project, you're going to do stage 1 during the PID. Stage 2 during the PNED. For Caltrans staff that are doing traffic investigations, if you're doing what we call a TIR, traffic investigation report, then you could do the stage 1 of ISOAP if you have enough information. You could actually do it prior to initiating a capital project. Conversely, if you don't have enough information, you could actually initiate the capital project, open up the project EA, and you could wait until the PID is open for the stage 1 of ISOAP to be done. If you're doing an investigation and it calls for instance, changing a 2-way stop to a 4-way stop, and if you decide that's the right decision, then you have to open up stage 1 of ISOAP just to kind of document the decision process. So prior to doing the maintenance sign installation order, you'll want to do that stage 1 of ISOAP. For local development review, so this is typically when a developer wants to do an improvement that affects the state highway. Very oftentimes it's having a new access point, a new driveway to a shopping center, for instance. Typically, we will be asking for ISOAP to be done during the planning process, during local development review. That way, when the developer is going to be applying for an encroachment permit, typically the documentation is going to be a peer. We want the ISOAP to be completed prior to doing the peer. However, if it's a more elaborate project where there's actually going to be some kind of a PID document, if it's going to go through the QMAP process, for instance, then you could actually defer ISOAP until you're doing QMAP. Okay, very quickly covering some of the roles and responsibilities. So I just want to cover two key roles. One is the ISOAP engineer. So the ISOAP engineer is the practitioner who is almost like the project manager of the ISOAP process, gathering all the information, the documentation, getting information from the project engineer, from the traffic operations engineer, from the traffic safety engineer, compiling the data, and documenting it. So the ISOAP engineer will very typically be a traffic operations engineer. Doesn't necessarily, it could be a project engineer. The other thing I want to point out, it doesn't even necessarily need to be an engineer. It could be a transportation planner, it could be a technician. We would just recommend that the activities be done under reviewed by an engineer. The other responsibility I want to cover is the district ISOAP engineer. So this is going to be the Caltrans staff person within traffic operations who's going to be providing the support for ISOAP. Also will be reviewing the documents for completion, for routing it, for approval. So every district will have at least one ISOAP engineer. And I've listed the names of the current ISOAP engineers. The one thing I also want to mention is later on, I'll be talking about the training. If there's some specific training needs or questions, feel free to reach out to your district ISOAP engineer. These names are also posted on the Caltrans ISOAP website, so they'll be kept up to date over there. So just moving on, I want to briefly talk about some of the analysis tools. And again, I don't have time to go into detail, but during the screening process, there are some computer programs that can be used to help determine what are some appropriate intersection control treatments to be looking at. So FHWA has their safe system for intersections methodology, where it kind of compares different types of intersection treatments that are appropriate for some specific traffic movements and patterns. FHWA actually also has an ICE tool where you also input volumes and other kind of data, and it's going to give you what the most likely intersection treatments can be. Virginia DOT has what they call the VJust tool. So a more experienced practitioner will, by looking at the existing intersection, looking at the traffic volumes, looking at the conflicts, the collisions, will be able to, for the most part, be able to make the judgment as to what are the most likely feasible types of intersection treatments to look at. But for the more novice engineer, this is some tools that they could potentially be using. For safety analysis, FHWA has their SPICE tool. As I mentioned before, if you have to do stage 2 of ISOAP, we do have a requirement of using the highway safety manual if it's applicable, but we know in many situations it is not. So you'll be wanting to use do a more quality analysis. So other tools we have is our safety index tool, and specifically for roundabouts, we have the collision cost analysis tool. But safety programs is doing a lot of updates to their various collision tools right now. So there'll be changes in probably the 1 to 2 year time frame where these tools will be updated. As far as operational analysis tools, FHWA has their CapEx tool that can be done during the screening. And the more traditional traffic engineering tools, when you have traffic volumes and looking at intersections, highway capacity manual, we have Synchro, which is based upon the highway capacity manual. Vism, particularly for corridors. For analyzing roundabouts, Sidra is our preferred software. There's also Rodel, which is an alternative software for roundabouts. Specifically for pedestrian and bicyclist analysis tools, there are multiple, starting with the highway capacity manual, but there's also the bicycle level of traffic stress, which was developed by San Jose State University. A new tool is called the Design Flags Calculator tool. And this is by looking at various flags, which I'll show in the next slide. You're comparing the number of flags that a particular type of intersection treatment triggers. So if you have fewer flags, then theoretically, it may be a potentially safer treatment or a treatment that there's more user comfort. And so these are just the flags that it's generally it's a qualitative analysis of an intersection. Okay, so the next section, actually, Daniel, are there any quick questions that we could answer before I get to the next section?
Yes, thank you so much, John. We do have a few questions here. Can we go through the ISOAP process and still not proceed with the recommendation?
Yes. So ISOAP is only a recommendation, but as far as who actually makes the decision as to what type of intersection, form, or control, that is going to be the project development team. The PDT makes that decision for capital projects. For encroachment permit projects, ultimately, it's the district director. So if the recommendation does not line up with what the project proponent wants to do, there is that process where the actual decision maker may choose to discard what's recommendation. But at least the facts were presented and an informed decision can be made.
Excellent, thank you. The CapEx includes many more options compared to SPICE. How should we handle the preliminary safety assessment when SPICE doesn't have as many control options?
Yeah, and use these programs with a grain of salt. Use a lot of engineering judgment. You never want to just use whatever a program spits out, and then out of that black box is what you're going to be using. You're always going to want to evaluate and ask the question, does this make sense? Are there other alternatives? So don't just automatically go with what these programs are suggesting to use.
Good analysis, thank you. We have a question and then a comment, and then we'll move on to the next section. Adjusting signal timing might impose operational performance of the intersection. Why is ISOAP not needed in this situation?
Okay, so if I understand the question correctly, if you want to just make some signal timing changes to an individual signal or a corridor, why do you not have to go through ISOAP? So ISOAP is a framework to analyze, but generally, if you're going to be doing fine tuning to signals, you don't have to be looking at various alternatives. If you're just trying to improve the performance, and absolutely, you should always be on an annual basis or every couple of years, because as traffic pattern changes, you want to make sure that you're operating your intersections as efficiently as possible. But making signal timing changes is a low-cost endeavor. ISOAP is meant to help guide investment decisions. So if it turns out that you've tweaked the signal as much as you can, and now you're at the point where you actually perhaps have to do some expansion of the system, that's what's going to be triggering ISOAP.
Some very good analysis again. We do have a comment here from Gina Lopez, who is one of the subject matter experts on roundabouts in the Division of Design. I agree there isn't any conflicting guidance within the Highway Design Manual Index 40510. And this, I guess, refers back to an earlier question that we had, where it specifically states that ICD ranges that are referenced in the Highway Design Manual are typical values, so they may be larger or smaller as site location constraints and performance checks will determine if the diameter is appropriate. So 40510 also states that mini roundabouts may be an acceptable design. So we see where it doesn't conflict with the guidance in the Highway Design Manual. Thanks again, Gina, for adding in. And one last one here is just a quick comment. So this is following up the ISOAP process, and if we need to follow through with the recommendation. So who would make the decision if it's for a TIR?
Okay, so TIR is done internally at Caltrans. So TIRs are typically done by a traffic operational engineer, or it could be a traffic safety engineer. If they're going to be initiating a change, then they should be preparing the ISOP if it's going to end up with being a sign installation order. You know, as I mentioned earlier, going from a two-way stop to a four-way stop. But if they're going to be recommending a capital project, you know, for instance, proposing a traffic signal, proposing a roundabout, typically what they would do would be doing a pre-PID document, a conceptual report or a similar type of document. And then when the project gets assigned by a project manager and the PID is open, then during the PID phase, typically it's going to be a different functional unit that actually writes the PID as well as doing the ISOP analysis.
Thanks again, John. Let's go ahead and continue on through the presentation. We'll take questions again at the end of the next section.
Okay, very good. So yeah, I'm going to very quickly go through the various stages and steps of ISOP. So the first thing is determining whether or not you have to do ISOP, and I've already talked about the criteria. The one thing I do want to mention is there is a exception process that if ISOP is required, but you don't want to go through ISOP, then we do ask that you talk to the district ISOP coordinator. They will need to get concurrence from headquarters traffic ops and safety programs not to do ISOP, but we're hoping that there are very few or no exceptions to doing ISOP. So you want to figure out what are you trying to solve or do with a particular type of change. A lot of times it's going to be improving safety, improving operations, reducing the queue. It may just be calming traffic, but we want to figure out what is the need for the project without trying not to use language that is too much into the environmental realm. So I'm not saying this is the need and purpose, but it's kind of along the lines. What do you intend to do to accomplish with your proposed project? You want to gather as much data as you can, because during stage one of ISOP, you're not required to go out and actually do traffic counts, do a lot of analysis. You just want to gather as much data to figure out what has already been done out there, what kind of planning studies, for instance. So you're gathering traffic data, you're gathering planning data, you're determining what the appropriate context is, what the land use is, and how the highway eventually is going to be configured in the future. It may be a rural two-lane highway now, but a few years from now, it may be a suburban or urban conventional highway. So we want to see, determine how do we envision the route to look like in the future? And we want to start being prepared to accommodate pedestrians and bicyclists, for instance, if we expect this location to become more urbanized. So determining the place type is very important. You want to determine what the design vehicle is. And Caltrans has various truck maps that we could refer to. We have different truck access managers who could be consulted. And we want to do a qualitative assessment of the bicycle and pedestrian facilities. And this is back to the context which I was previously talking about. And if this area already has pedestrian and bicyclists activity, you want to figure out what are some of the gaps, what are some of the needs that could be addressed. Look at the schools and the senior centers and if there's any kind of special populations. And get ideas as far as the right-of-way. What are some of the constraints? If you want to lay out a roundabout, what may kind of be some issue locations as far as getting that footprint. So here we're kind of using our experience based upon typical volumes of this type of facility, the sizing based upon the type of truck you're designing for. You're not doing a very rigorous analysis with performance checks. Here you're just trying to get a general footprint to figure out what seems to work and be reasonable at this particular location. I talked about the tools earlier that you could use just to kind of, you want to get to maybe 2 or 3 and not have too many potential alternatives at this point. But look at the most viable. We do have a worksheet. This is primarily for the more novice engineer who may not be familiar with a lot of the treatments. But as I mentioned before, someone who's very experienced will be able to kind of target the 2 or 3 types of treatments pretty quickly. We want to look at the transit needs as far as bus stops, both now and the future, rideshare drop-off locations, casual carpool, bus shelters near a far side, because increasingly transit is going to become more and more important. And also looking at freight. Here we want to go beyond to what the design vehicle is, but are there oversized vehicles that need to be accommodated? So we're talking to our transportation permits folks up in Sacramento. We're looking at the industry. Are there industrial areas? Are there agriculture areas that we need to be accommodating large trucks? A lot of our roundabouts in District 6, we're accommodating these low boy booster trucks. These could be 200 feet long. So we may have to look at alternate routes if we're designing a roundabout that may constrain. But if we have to accommodate, then we have to figure out how do we accommodate. And a lot of times trucks don't have to make all movements. So we need to look at where the truck's coming and going to. We do a quick safety analysis. If we have access to the collision data, we want to see what the collision patterns are. But we're also looking at the relative safety of the various types of potential intersection control strategies. And I talked about the SPICE tool earlier. And then we want to eliminate the infeasible strategies. If the footprint of a roundabout doesn't work not because you're taking a parking lot, you could generally take a parking lot, but if you're taking a historic building, more than likely that's not going to happen. If there's going to be a PG&E transmission tower that has to be moved, more than likely you're not going to be able to do that. So you're going to want to look at constraints and just use a lot of engineering judgment. What makes sense? We don't want to say if you have to acquire right away, that automatically is going to disqualify any kind of potential treatments. But we want to be reasonable. What could we potentially do with what funding is available, or what funding could potentially be available? And then we document the findings. If there is only one viable solution, then you're pretty much done. You don't have to go to stage 2. If there is only one viable strategy, but you're short of funding, then that's where we want to get your thinking cap on and figure out what could we do to get more funding? What can we do to make an alternative more affordable? What can we do for the interim? And then we're going to be filling a form out, and we're going to do some, the routing to the safety engineer if we're going to be concluding the process. So we have some existing Excel forms that are available on the Caltrans ISOAP website. We are in the process of developing a little bit easier to use fillable Microsoft Word forms. So we're going to have these posted on the Caltrans website within a few days. But as I mentioned before, you're not required to use these forms. It's just it's an option. And we do have a short form and a long form. The short form is very similar to the Excel form that we already have out there. But the idea is if you have multiple locations with repetitive information, then you may want to use the short form for a lot of those repeat locations on the same corridor. Or if you're just going from a two-way stop to a four-way stop, then use the short form. The thing with the long form, it really provides some step-by-step guidance. So I kind of feel it's very easy to follow the long form. So if you have to go to stage 2, this is doing the detailed safety analysis initially. And as I mentioned before, the requirement is using the Highway Safety Manual if it is applicable. And if you can't use the HSM, then you could do a more qualitative safety analysis. Or if there's other tools that you could do a quantitative safety analysis, that's what we would like you to use. During stage 2, you're also going to be having the traffic counts, the traffic projections. So you're going to be able to do a very robust analysis using the various tools. So you're going to be analyzing for the appropriate periods. And we have kind of moved away from level service. So in general, you'll be using the daily person hour delay, DPHD, for your mobility measure of effectiveness. But maybe it's going to be something else. Maybe you're designing a project for the downtown location where you're willing to live with congestion. And the local agency may actually have a level service F standard. So maybe what's more important is looking at queuing, making sure that the bus is going to be able to get through the corridor without being gridlocked. So you may be looking at transit priority, maybe looking at transit only lanes. So there's different treatments and measures of effectiveness that you should be considering in situations. If you're designing signals, intersections, or roundabouts in particular, you're going to want to be doing performance checks because you really want to make sure your footprint is going to be appropriate. The sizing is going to be appropriate for the traffic volumes, for the type of vehicles. And then you're going to want to be doing developing a cost estimate, and the expectation is going to be the project engineer will be developing a PA and ED level cost estimates. And we're going to be able to calculate the benefit cost ratio and then present the data in a performance-based matrix. And I'll be showing this in a few minutes in an example. And then finally, we document in the stage 2 form. The highest performing alternative will generally become the recommendation as long as it's going to be satisfying the safe system approach, which we want a narrative to kind of describe how it supports it. And again, the costs may exceed what's the available funding. So get your thinking cap on as to how you may be able to get more funding if you need to get more funding. You submit the forms to the district ISOAP coordinator. That person's going to be routed to the district traffic safety engineer. And then finally, the district ISOAP coordinator will be providing comments and approval. And similar to the stage 1 form, I have a stage 2 form that's kind of short. So there is no long or short form. It's just going to be a stage 2 form, or you could use the Excel spreadsheet that we already have posted. One thing I want to note is public outreach. Caltrans, we're doing a lot more engagement during our project delivery process. And because ISOAP is being done generally in parallel with the project delivery process, public outreach should be built in to how projects are being developed. But if for some reason you're coming up with a new alternative or intersection treatment where public outreach has not been done and there's no further plans for public outreach, you may actually have to go back out to the public to make sure that we are doing appropriate levels of engagement to the folks that will be affected by the project. And other thing I want to mention is public education may be necessarily when you're implementing a novel approach, particularly if we're doing a roundabout that's going to be the first in a specific geographic region. In District 6, we dealt with those issues early on 10 years ago, But after you get a few roundabouts in, people understand how they work, and generally the opposition dies down. At this point, are there any questions before I get into the case studies?
Oh, yes, there's 4 questions.
Alrighty.
Is ISOAP analysis mandatory for all federal and state-funded projects? Is ISOAP required for projects that are currently in the project approval and environmental document phase?
Okay, so ISOAP doesn't consider the funding source. So regardless of the funding source, if it meets the applicability criteria, ISOAP will have to be done. So when we issued the memo for ISOAP, we did provide some grace period. If you have already initiated a project using ICE, we said that if you're able to complete it by November 15th, you don't have to go through ISOAP. So if someone hasn't concluded ISOAP, I would say work with your district ISOAP engineer, and we want to do what makes sense. If you need a transition to actually do the ISOAP, or if we're going to be okay with just following up and wrapping up the ICE process. But the thing I want to emphasize is, to me, ICE to ISOAP, there's more direction, but other than the highway safety manual, I don't see there's anything that's going to be very burdensome from going to ICE to ISOAP. Okay, next question.
So what is the typical source for the collision history?
Okay, so particularly for the local agency or consulting engineer, this is where we're going to ask you to work with the Caltrans staff within the traffic safety units. They will generally prepare a collision summary of a location. They won't necessarily provide you a collision diagram, but they could tell you, this is the collision history, these are the collision rates. So talk to your traffic safety folks. You may have to go through the CPRA process to get that data. But again, talk to district folks, and when in doubt, always work through your district ISOAP coordinator.
Don, I'd also like to point out that there is a wonderful tool called the Transportation Injury Mapping System, which will share a lot of that data. Although most of it is on the state highway system, there are some that are reported on the local roads by the California Highway Patrol. And I'm going to drop that into the it's called the Transportation Injury Mapping System. So I'm going to go ahead and drop that in there for anybody who's interested, and you can kind of go in and look at the data and do your own assessments.
Yeah, at Tim's data, that's a great first step to kind of see what's out there. It may not give you all the detailed information, but for a first step, that's great data to access.
I believe so as well. Thanks, John. When do we need to, or when would you like the local agencies to consult with Caltrans on the process? Does it depend on the project funding, perhaps the road classification? Specifically, or for example, what if a locally funded project on a local road, will Caltrans formally consult, approve, or just informally upon the request when it's provided?
Early consultation is always the best. So work through the planning division, and what we kind of expect is just to have a quick consultation to see what's in the realm of possibilities. Looking at the type of highway facility, ideally in the planning process and going through the planning documents, whether it's a route concept report or a multimodal corridor report, we would like to see kind of this the vision of what a corridor is going to look like. Where the access points, the spacing of the access, the type of traffic control. Ideally, that would be addressed in these multiple corridor documents. But absent that, talk to the district planning and traffic staff, and they'll kind of give you an idea of early on what's going to be some of the viable solutions, and then what is the proper timing and the process that should be followed.
Great answer. Lastly, before we move on to Section 9 case studies, some, if not all, of the steps within Step 2 of the Highway Design Manual are part of either the TOAR or HSM analysis. Do we need separate documentation for ISOAP that combines the results of these analyses, or will these two documents in their current form suffice?
Okay, so currently the tour is a separate document. And if you want to just refer to the tour in the ISOAP document, or if you want to just provide a summary within the ISOAP, that's all you need to do. But at this time, we don't have a combined document. So again, I would just suggest that you refer to the tour or just do a summary of what was the tour and put that in the ISOAP document.
That is it for questions. Back to you, John.
Okay, very good. So the last section before taking additional questions is talking about case studies. But before I get into specific ISOAP case studies, I'd like to introduce Phil Rust from City of San Diego. And he's going to talk about some of the experience about affordable roundabouts on the local system. So Phil, why don't you give you a quick introduction, and then you could go ahead and get into your slides.
Thank you, John. Yeah, Phil Rust over here, traffic signal engineer, traffic operations engineer, traffic safety engineer with City of San Diego. Wear a few hats, but sure appreciate your leadership, both with intersection evaluation and also with roundabouts. And I just wanted to make kind of 4 key points with what we want to share as far as low cost modular roundabouts. First of all, the cost of them. This is really kind of all the difference when you're comparing 2 things, let's say a roundabout and a traffic signal. If the roundabout is the more effective, safe solution, and it costs a little more than the traffic signal, then you're having to defend yourself. Why spend the extra money? Why do you have to do that? What's the value add? Once you get to a point where the roundabout's costing less than the traffic signal, it kind of switches things, put the signal in the hot seat. Now you have to defend, why not? And so that just puts kind of the wind at your back as far as once the cost of your roundabout drops below that of your alternatives. Second point, on modular roundabouts, super easy to remove. And the key here is really that if you can take it out, then you don't have to be quite as rigorous or forward thinking or as far out thinking as you would if it was such a permanent sort of immovable thing that was very expensive to remove. In other words, if you're looking at 20 years out, hey, I've got to put a second lane in here maybe, or because I can easily just remove it and expand it later, I can just go with the single lane, which works today. It'll give me 5 years, 10 years, maybe 15, all good, very easy to remove. And so it sort of takes that, it just makes it easy to defend going in with a single lane at the beginning, which is, not only like smaller, 30 feet smaller as far as the ICD or so, but also much simpler for the public, much easier to kind of get on board with. And so they're going to be happier and also a bit safer than the multi-lane option. So definitely helpful there. And then just about roundabouts in general, kind of want to make some points here. 2 essential key elements of safe systems, and roundabouts embody both of them. So I'm going to kind of go into that a little bit. And then finally, talking about how roundabouts are they're really unique, actually, in terms of operations and safety, that you don't have to make a trade-off. In fact, overall, like along a corridor, if you had a corridor of roundabouts, you're going to see the travel time actually go down, which is kind of unexpected because you're also reducing speeds. So with slower speeds, you'd expect maybe a higher travel time, a longer travel time, but actually we see, because it eliminates unnecessary stops along the way, actually travel times go down as well. So it's a plus for safety and for the environment, and for really the economy in the area. So So yeah, back to that first point, talking about saving money. Here, 3 examples here from San Diego. The first one at the top, in the $2 million kind of range for a traditional concrete roundabout. And this one has been under construction actually for over a year, but it's been in the works. I think I started outreach for it about 6 or 7 years ago. So very long process, very expensive traditional strategy. Our second, the second one here in the middle is actually our first quick build, our first modular roundabout. And you can kind of see in there the green portion is the recycled plastic, as well as the yellow outline portion there. So the whole thing was just bolted down. It only took a couple of weeks to bolt that down, and way less cost, about 10x lower cost. The most recent one we've done, the second one we just installed last month. Down at the bottom here, you can see the red is the recycled plastic part, and then the white is just paint. So kind of a high durability paint. And that one just went in about 4 days, and about half the cost of the other modular one. So about a 20x impact, or 20x improvement in cost versus traditional roundabout. So go to the next slide here. We can see a little more detail on these raised portions on the left. So just, kind of calling out the idea to only along the perimeter. And so that makes all the parts interchangeable. And so we can, not only install them much faster, but it's just much simpler to put in. So this is kind of the cutting edge innovation that we're working on right now, trying to put more and more of these around San Diego. Go ahead. All right, so second point really on removability. You can go with today's traffic volumes. That really means you don't have to overbuild for the future. And kind of 2 things happen when you forecast out. One, the future traffic volumes are a bit of a guess, and you like to be conservative, so you kind of might inflate those. But secondly, the capacity analysis tool that you're using is also a bit of an estimate. So tend to be conservative on that, and also inflate a little bit. And so that's kind of the danger that we get into when we start getting there. And if really 1 lane versus 2 lane is the key. You want to go with the 1 lane if at all possible. And so this really allows you to not build in all that guessing and just go with a 1 lane if it works today. The kind of backward way of backing into this and seeing, hey, is that okay? Most of the roundabouts that have been built with expandable features across the country have not needed to be expanded yet. So they've lasted much longer than the models forecasted they would. Just a quick example, our first modular, we had an always stop there. We removed 2 bypass lanes to fit it in, and it works great. But similar delay performance as the always stop. And then the second modular I was just showing you with the white and the red, that one we removed 2 through lanes to install that one, and that is going great as well, even better in terms of delay. So just to note, also roundabouts tend to handle more traffic than a signal does within the same lane, so same number of lanes. And then also with that amount of traffic, even if you had the same amount of traffic, you tend to get less delay with the roundabout compared to a traffic signal. So there's just a reference here on the capacity equation I was mentioning. Next slide. So as we get into talking again, I'm going to kind of repeat a little bit about safe systems. Comparing it to the traffic signal, roundabouts have an incredible track record in terms of safety. So we have a couple of states, Pennsylvania, South Carolina, they've done studies statewide that had 0 fatal crashes at any of their roundabouts. But there might be some, and so in other states. And so the really impressive stat though is that across all of the United States, we have 0 fatal crashes in any roundabout crosswalks. And so with 10,000 roundabouts and counting, many of them 20 years or more old, incredible performance. So that's essential to kind of keep in mind. But the next few slides, I want to talk about why that might be or how that happens. So to make a safe system, you really have 2 parts to it, two as far as the engineering side. One is redundancy. So people make mistakes. There needs to be something else in the system that catches that mistake and compensates for it. So that's what redundancy is. And then secondly, people are vulnerable. So if a crash does occur, is the crash energy low? Our intuition about the relationship between speed and energy is fairly linear, but in actual fact, the energy involved in a crash it increases as a square of the speed, actually. So it's far more dangerous the faster you go. And you can also see here a little bit about the angle. If it's a head-on, obviously the speeds add. So it's an 80-mile-an-hour crash of 240-mile-an-hour vehicles. T-bone 40, rear end 20. So the angle makes a big difference. Okay, so talking about redundancy now, people make mistakes. How can you spot and compensate for that? And this is just an example at a traffic signal. So the yellow car is the one approaching on green. The blue and the orange cars both have a red light. One of them is going to run it. So you don't know which one, and you need to be able to spot it far enough ahead that you can take action and slow down and stop before you enter the intersection and get hit by them. That's almost an impossible task. It may be impossible in many cases if you don't have the sight distance. And in almost every case, when you have a green light, you're not looking. I don't. You know, it's kind of scary to think how we aren't checking to see if someone else is making a mistake so we can compensate for it. And that ends up kind of leading to this issue that we have with the fatal crashes. Now, with a roundabout, you do have redundancy. And so people are interacting with each other, the pedestrians crossing, the drivers, they're looking at each other to see what, you know, who has the right of way, what's going to happen next. And so if somebody does in fact make a mistake, even if you have the right of way, you're going to be able to see they're making a mistake and you can compensate because they're going slow enough and you're going slow enough. The other key kind of thing is that these interactions are simple. So as you're entering, before you enter, all you have to do is look for the crosswalk. If there's no one in the crosswalk, then you're moving forward, then you can see if you can enter. Once you're in the circle, you'll be able to see if someone else is entering and maybe taking your spot, so you can compensate for that. And then on the exit, looking at the crosswalk again. This is in great contrast to an all-way stop, where at the entry of an all-way stop, you actually have to you know, consider who goes next as the same time as you're looking at your crosswalk and the crosswalk where you're headed. All 3 things have to align. It's very complicated. Roundabout's very simple. Also, you only really have to look one direction at a time if you're a pedestrian crossing or a vehicle entering, that sort of thing. So for a safe system, does a signal have redundancy? No. A roundabout, yes. So that passes the first test. Second test, speed. Particularly with the roundabout here, we show the example as the radar gun is measuring speeds of vehicles as they approach. As you get closer and closer, you see the 13 mile an hour there above C lines up with the crosswalk there. That is the slowest point. So no surprise maybe that no one has been killed in a roundabout crosswalk yet. And also, oops, go back 1 second to just note that the deceleration going on all the way up to that point. So that's just showing the drivers have their foot on the brake all the way up to that crosswalk. So that's critical to the performance there, their likelihood of being able to stop in time. Go ahead. So just to kind of reiterate that point here, at a green light, there's no speed control at all going through at full speed. Versus a roundabout, not only do you have a lower speed as you're approaching, but also you can see the curvature there. So that helps as well take energy out of the crash if one occurs, because it's at that slow or less of an angle. So side swipe type. Go ahead. Okay, so last slide for me, just talking about this concept here where you don't have to trade off safety and operations here if you're going from an always stop to a signal because you need the efficiency, then you have to trade off the safety there. And so the cool thing about a roundabout here, it's pretty unique. Not only is it more efficient, it's also way more safe. And so you're actually getting benefit on both measures. And so again, mentioning that even though it slows vehicles down at the intersections, it eliminates all the unnecessary stopping, so your travel time also improves along the corridor. So that's all I have. Thank you very much, John.
Great, thank you, Phil. And ISOAP is not just about roundabouts, but we do know that roundabouts are one of the safest forms of intersection. And that's one reason why in District 6, we've been very aggressive in having roundabouts installed. We've built 14 in the last 10 years, but that number should triple in the next 5 years as we do have a lot of roundabouts in the pipeline. The case studies, I'm only going to spend 1 to 2 minutes per case study, so not get into a lot of detail, but just kind of give you the concept. But I mentioned earlier that we are going to have in-person workshops, and maybe we'll do some virtual workshops where we will be able to get into the case studies a little bit more in depth. So the first case study I want to talk about is a proposed roundabout in Mendota at Highway 33 and 180. This is just west of Fresno. So the city originally applied for a CMAQ grant to install a roundabout. So, going through the steps, do we have to do ISOAP? Yes, absolutely. So I think I just want to get straight to, kind of the pertinent details. Initially, we did signal warrants, and obviously it showed that the roundabout would work much better. But this was a location that had a lot of controversy. So that's why we spent time actually looking at the signal alternative. And the concept was actually relocating the intersection a little bit north to next to a fire station, McCabe. That's where there was a lot of traffic at a middle school. But this realignment of the highway was actually very expensive. We found that it would not be affordable. So we actually were looking in the more detailed analysis of relocating the intersection to the actual current intersection. So the thing I want to point out is, this project is already in the pipeline, but if we were going to be doing ISOAP, we would require a highway safety manual for stage 2. And so this is where really need to work closely with the districts, and actually with headquarters design, they'll actually have to be doing some of the computer work. So highway safety manual, if you're not familiar with it, there's crash modification factors that have to be inputted, and you have to determine what are some of those appropriate factors that will be utilized. So I don't really have time to get into detail, but doing the mobility analysis, as I mentioned before, we're using DPHD, daily person's hours a delay. And when you're comparing the roundabout to the signal, it shows a lot of benefit with the roundabout. So I don't have time to get into the details, but I did want to talk about the benefit cost ratio. So in this situation, the traffic signal was actually more expensive than the roundabout, because as I mentioned before, there was a realignment costs. From the highway safety manual, it showed slightly better outcome with the roundabout compared to the traffic signal. But when it came to the mobility, much higher benefits with the roundabout. So when you do the matrix, we get an overall benefit of 17 versus 4 benefit cost ratio for the roundabout. So obviously the roundabout is the much better solution. And this is one reason why we have the streamlined process. This is a lower volume, less than 25,000. You could go automatically to the roundabout because we know we're going to have better operational and safety outcomes. But this was a location that did have some controversy. The second location I want to mention is downtown Madera. So we have a pavement rehab project. We have a 5-lane cross-section, and the city really wants to improve the aesthetics and the economic outlook of the downtown. And one thing that we decided to do, want to do a road diet so we could add bike lane, but obviously you'd be losing a lot of capacity by doing the road diet. So I suggested introducing, at the time, mini roundabouts to kind of recapture that lost capacity. It turns out we're actually able to do urban compact roundabouts. So it won't be a fully traversable mini roundabout, but it will be very compact. We will still be able to accommodate STAA trucks to make the through movement. And this will be like a 95-foot ICD. So it is going to be fairly compact. So as Jerry mentioned before, this is one way how you could do road diets. And keeping the traffic flow, we're actually able to get credit for doing the road diets because of the VMT world and apply the reduced lane mileage and get credit for other projects as we're doing the environmental document for this. The next project I want to talk about is City of Kerman, and a shout out to Jose Benavides, JLB traffic engineer. I know he's on the call. And the school was building a new athletic facility across the highway from where the high school was. And we suggested early on about placing a hybrid beacon, pedestrian hybrid beacon. The concern is Highway 180, eventually there may be an expressway bypass, but it is a very important corridor. We want to maintain that half-mile signal spacing. By introducing another signal, which the city wanted, we just felt that it's going to have issues in regards to mobility, but we want to have the safety outcomes, and we felt that the pedestrian hybrid beacon would be the appropriate treatment. So went through ICE, and these are some graphics from JLB Engineering as far as a roundabout, which was not found feasible. And then this was the hybrid beacon, which ultimately is going to be constructed. The next example is an R-cut in a rural environment, kind of like an offset intersection. We previously put a worm at Road 180, which is the west intersection, and we were starting to have collisions at the east intersection at Road 182. Ultimately, we decided that we are going to be putting a worm. So we went through, and this is a location where we're actually going to do the ISOAP. So this is a natural project that we're going through right now because we are doing some widening to add some acceleration lanes. But so far the analysis shows that an R-cut treatment is the best solution. The last case study is going to be an interchange. This is in Tulare County at Page Avenue. A very antiquated rural interchange next to a big truck stop. And we looked at 3 alternatives. One was a DDI that actually has a roundabout. And this is where Caltrans staff did some very preliminary graphics or geometrics. And we just found that it'd be very difficult to accommodate that 5-legged roundabout and be very complicated. We decided we wanted to go with a more traditional configuration. So we looked at 2 roundabout treatments. One was actually a single roundabout, kind of like a single point, one large roundabout right on top of the freeway. And the second alternative was a more traditional tight diamond roundabout treatment. Ultimately, this is the decision treatment that was decided. So this will be under construction soon. That's all the time I have to go through the case studies. To wrap up, do want to mention that for support, we do have the ISOAP website. We have a technical assistance program. So we do have various Caltrans members, including myself. I mentioned the upcoming workshops. So we do have in-person workshops. They're being planned for districts 4, 6, 7, 8, 11. We potentially could have additional workshops or virtual workshops. So talk to your district ISOAP coordinators if you're interested in participating. And if we do have a quick minute, I do want to see if Robert Peterson is online to make a very quick announcement. So Robert, are you there?
Yes, I am here.
Okay, yeah, Robert, why don't you introduce yourself, and you have about a minute to make any kind of announcement that you need to make.
All right, let me turn my camera on here. There we are. Let me get my all right. Sorry about that. My screen's up here, my other screen, so it looks like I'm looking up. But yeah, so I'm Robert Peterson. I'm the office chief over the local 8-SIP program. So as most know, we just did cycle 12. We did the reviews of that. I'll be retiring here at the end of this year, but that doesn't mean the cycle's going anywhere. It's being worked on with my team, and we're looking to fund. We got 330 applications for the last call. We're looking to fund the majority of those. We have maybe around 280 to 300, don't quote me on that, to probably to fund those applications. So probably everyone that every agency that applied will at least get one or more of the applications funded. That announcement expected to come out sometime next year, probably January, optimistic February. Reality, we're the reality part of it, and we're working to get that out and work with our PIOs because we want to broadcast the projects that we're funding. So very good applications this time. We got some really good roundabouts. Maybe it was shared earlier, so we're hoping to continue that with, as we've shared today, with more funding, more roundabouts in the future, and adopting the safe system approaches you've heard. So thank you, everyone. It's been a great career, and like I said, Richard Key and Kelly Marr, my safety managers, are still here and to assist, and of course with the 8-SIP coordinators in the district. With that, thank you.
All right, thank you, Robert, and happy retirement. And Daniel, I'll pass it back on to you to close us out. I will mention that we will be providing written responses to all the questions. I know there's no time for any other questions, but we will be answering those in written form, and we'll be sending those out. So Daniel.
Thank you so much, John. We do have a quick question here, but again, congratulations to Robert Pearson. Great career here at Caltrans. Wish you best adventures in the new chapter that you're about to embark upon. And also, great reference there, John, with the in-person trainings with the case studies. That's awesome. And we have a question lined up right behind that fits right into there. Are there any approved ISOAP documents, such as a template perhaps, that can be used as a reference when preparing a new assessment?
Yeah, so I will be posting an example of ISOAP. So I'm actually going to be using the Minota example. That will be posted on the Caltrans ISOAP website in the next few days, as well as the new fillable Word forms.
Do you have anything to say there, Robert? I might have cut you off. My apologies. All right. Well, thanks everybody for attending. We're going to go ahead and post the training here eventually onto the CalTap website, which is www.caltap, and that'll be through their YouTube channel. We'll come out with an e-blast on it next week. Hopefully it'll be up by next week. And wishing everybody a great afternoon, and hope everybody enjoyed the presentation. The presenters can just stay on another minute longer if you are able. Thank you so much, everybody. Have a great and safe afternoon.